customer case studies. And I want to welcome Tony Damiani from Cornell University, who's been so kind to share his experience masking personal identification information in their PeopleSoft application. Tony is the Assistant Director of Business Intelligence at Cornell, and he's been with Cornell for over 20 years. What we'll do is we'll have Tony go through his presentation. We'll do Q&A at the end of the presentation. As you come up with questions, if you can go ahead and send them to the host, and the host name is Chandra. We'll then go ahead and take the questions, and at the end, I'll read them off to Tony so he can go ahead and answer them. So without further ado, let me go ahead and turn it over to Tony. And again, if I could ask everybody to go ahead and mute their phones just to block any background noise. All right, Tony?
Thanks, Russ. As Russ mentioned, I've been at Cornell quite a few years. I'm currently working in the BI space, but during the time of this project, I was in the database administration area, so I've kind of floated back and forth between the two areas. Anyway, our agenda for today looks like this. We've done our introductions. I'll give you a little blurb on Cornell, talk a little bit about our environment, some of the challenges we face, some alternatives considered, the results of this project of using the data masking products and masking data in PeopleSoft, a couple lessons learned, and a few recommendations, and then open it up to any questions people might have. So Cornell, just in case you don't know what Cornell is, it's an Ivy League school. It was founded in 1865. It's in upstate New York. It's a great place to visit in the summer and fall, and not so much in the winter. There's about 20,000 students on the Ithaca campus, so it's a pretty good-sized campus. And Cornell is a little bit different in that it's the federal land-grant college in New York State, so it has both public and private colleges within it. And so there are 14 or maybe 15 colleges now, composed, undergraduate, graduate, and so on, and there are public ones and private ones. So it's a diverse environment, and that helped drive part of this decision in terms of what solutions we went with to protect our data. So that's a little bit about Cornell. In terms of our environment, we have PeopleSoft Campus Solutions version 8.9. So we have all the student modules in play. We have HR and payroll, and we also have contributor relations, or the gifting modules, the development modules. So all those modules are in use, and they're all of them reside in one database behind the scenes. It's one consolidated database. It's an Oracle database. It's at the time of the project, it was version 11.1. We're a little further along now, but basically it's an Oracle database. And also, off of our PeopleSoft environment, we have a lot of data marts we've built, and the associated reporting solutions that are attached to those data marts, and there's quite a broad audience that use the data marts. So that's what our environment looks like, and that's still pretty much true. This project that we're going to be talking about was from summer of 2010. A lot of the versions are at least fairly close at this point. So one of the challenges I think we were facing is we have a pretty distributed environment across campus. We don't necessarily have everything controlled centrally. We have developers and functional staff all over the place, and they don't all follow the same practices and procedures. So in some ways that poses a challenge when you're talking about protecting your data, or following something that says, don't do this or do that. We certainly try to follow a number of what we consider good or best practices centrally, but it's a little harder to control in other units. And what we see in this environment, since there are so many modules and it's so active, is at any given point in time we have maybe a tax and fix upgrade going on, or an enhancement or something, or other requiring people to test things. So they're running queries, maybe running SQRs, various batch jobs, reports, and they end up with data on their local PC, and sometimes they clean it up and sometimes they don't. And these days, a local PC is often a laptop, which is obviously at an added risk of something that travels off site with them. They may take it home, they may take it on a trip, they may, it can go anywhere, and so it has more potential for being lost or stolen. And from our experience was we had just that happen back in '09. A laptop was with a developer and it was stolen, and it had, we obviously didn't know what exactly it had on it at the time until we looked at the backup records, and they indicated there were a number of files on there with things like SSN and, bank account numbers, and just stuff that you did not want to have fall into the wrong hands. And so we were required to let everyone that we found in those files, on the file information, we had to let them know that we had to provide credit checks. We had to do a bunch of things that were not good for PR. Spent a lot of time explaining it to a lot of angry people, had a lot of phone calls, so on and so forth. It was not a good event, and certainly the president and board of trustees were not happy. And then, why mask data? Well, it was very obvious at that point that what we call one of our key assets, which is data, we had not perhaps treated as well as we should have, or put enough safeguards in place. So basically masking data is fairly key, and we'll talk about that a little bit more, and that's what this project was. And then follow this event. Obviously, if you do it before the event, you'll be in a much better situation. So, just to be clear, I think when people first hear about masking data, they think you're somehow putting a mask in front of it that can be pulled off and you'll see the real value. That's not what we're talking about. We wanted to have no chance to get back to the original value. We wanted to mask it in the sense of altering data, changing it to some non-real value but functional value that was not in any way sensitive. So that was the goal of what we saw in data masking. And it's part of your security solution. It's not a silver bullet, and it won't solve all your problems, but it certainly is something you can consider as part of your security protocols. And as I mentioned before, we're in a very decentralized environment, and the option of having protocol and practice be the only security measures, it wasn't very effective for us. So it's certainly a valid thought to say to have better practices around data retention and what you leave on your hard drive and things like that. Certainly valid points, but not something we can control easily. So when the event happened, we assessed the problem and came up with several possible solutions. As always, doing nothing is sometimes an option when you're writing a project plan. But we were told clearly by the leadership at Cornell that doing nothing was not an option. So we looked at manual masking, which, by that I mean you can write your own scripts and with your local expertise figure out where the data elements are in your systems and use RDBMS packages to randomize or mask or change the data. So it's certainly possible to do it manually, but the amount of time in going that route seemed to us not very cost effective. And as I mentioned, you can have more rigor and discipline in managing sensitive data, and certainly we've done that since that event in terms of how we work with data that's considered sensitive. Because as we mentioned earlier, this whole process does not affect production. This is a way that you secure non-production environments. So you still want to make sure when people are doing things in production and they're working with real data that they're following a much more strict protocol than they had in the past. And then there's just other solutions, encrypting laptops or using scanning software to look for sensitive files on people's computers and having them review the findings and see if they indeed are sensitive. And actually, we're doing a bunch of these things now. It's not either or. It's a defense in depth, as some of the security people call it. So we're doing a number of these things, and data masking is certainly one of the ones we picked for our ERP environment. To start the whole project, we had to really start at the top level so that we didn't spend a lot of time guessing on what were confidential elements or what were the highest risk factors. So we asked the data stewards, and actually legal was involved, and a number of other departments, in figuring out what data elements are considered confidential. And then once we determined that, we said that anytime these data elements are in systems, they'd have to follow stricter policies for security. And as it turns out, most of these elements were in our PeopleSoft system. In large part, that's where they live, and that's the data of record for them. And we're trying to make sure they don't get propagated elsewhere. And so in that case, we deemed that data masking was practical and necessary for the ERP environment. So that was the overall strategy after the event that we would move forward with. So for phase one, we were talking about PeopleSoft environment, and that really did cover most of our needs for Cornell. And as I'll repeat again a few times, it doesn't impact production in any way. That was probably one of the most asked questions, is how are you masking data in production? And it really isn't aimed at production in any fashion. You're going to basically mask all your other environments. And in our case, we have one production environment, and then we have many, many clones of production that are used for training or QA or what have you, that can have real data in them in the past, and still do, but at this point, certain confidential elements have been masked. And so we also have that issue with data marts having sensitive data, and we approach that a little bit differently, and I'll mention that later. So I think we chose a fairly modest number of elements to consider masking in this round of the whole project, and these are the ones that certainly are considered confidential, and if you expose them, or people lose a laptop with them on it, you're required to give people free credit checks and a number of things that are costly. So we started with this list, Social Security number being the big one, and then the obvious credit card number, driver's license, bank account numbers. And the patient treatment information is a broad set of elements that have anything to do with medical information that often ends up in the HR part of the system. So those were the elements we chose to mask for this project. So before I get into this slide, I'll just talk a little bit about what the project team looked like. We put together a project team last summer, and there was a DBA on the team, a developer, a data administrator, a project manager, and we also had a consultant from Solix to help us through the maze of how to go about masking our data. And from my perspective, I was the project sponsor, so to speak. So I organized the overall effort, got it moving, and provided status reports to the CIO and the presidents, people like that, so that they knew what was going on. Basically, what we were trying to do, from my perspective, that was a challenge, was how are we going to figure out where all these, for instance, all the SSNs that were in PeopleSoft, how would we find all the tables that had SSN, and how would we find all the tables that had bank account numbers? PeopleSoft's a large system. Ours has close to 30,000 tables, and doing that manually was just daunting. So that was where we looked to consulting, in particular Solix here, to have a library listing all those tables, providing us the metadata, so we wouldn't have to be basically scurrying around the PeopleSoft looking for things that look like SSN. So that was the one big challenge, and the other challenge is the algorithms mean. There's a lot of algorithms in the toolbox. So it was a matter of looking through the algorithms, understanding how they worked, what their limitations were, and that was once again where we looked for guidance from consulting and from Solix. So as an example here, Social Security number, what we were looking to do was to change the Social Security number from the real value to you could call it a random value. I think that's valid, but it would have to be unique. We didn't want two people ending up with the same random Social Security number, and we also wanted it to be consistent throughout the system. And by that I mean if John Smith's Social Security number was 123456789, we wanted it changed to a new random value, the same throughout the system, so that his data would still be valid even if the SSN was different. So it may be 3456789 123. It would be that throughout the system. So there was a need to have consistency applied, so you wouldn't see his SSN be one thing in one table and another thing in another table. And then there's also, like for PeopleSoft, you got to think about edit rules. You don't want to have the SSN generated to a random number that violates edit rules, else when people bring up a screen, it will cause problems when we're trying to look at the data. It will, try to say it's not valid if they're hit save or go through some of the screens. So there's a bunch of those things that you have to work through and document, make sure people understand, so that way you use the algorithms correctly. And in this case, we use something for Social Security number called a table column algorithm, and I'll talk about that one a little bit more in the next slide or two. And for bank account number, we use an algorithm called substitute. The point here being there's a sort of a library of algorithms, and you want to pick the one you want to understand what results you want to get, and then you want to use the right algorithms to get there, and that's certainly where getting people who are experienced with it will help you tremendously. So on this slide, it's a little crowded and it's a little bit technical, but not too much. I'll just make a few points here. The first point being along the top, where you have basically what we did was we surrounded the main step with a script or two, a masking prep script, and then there was a masking post script. So in general, the tool, like Solix and Oracle's tools, do a pretty good job at building what you need to do, but you probably want to wrap it with some scripting so it's very lights out when you're implementing it in your environments. And it has been lights out for us since we implemented last summer. We've had no problems with it, and it's worked fairly smoothly with no intervention. Basically, we run the scripts, it creates the cloned environments, and we're set. So the other point being, if you look in the middle of the slide where it says masking prep.sh, step one, for Social Security numbers, we had a unique challenge in, I think, the Campus Solutions environment because there's no master SSN table. Like say if you're just running HR payroll, you can probably go to the person table, and that's a pretty good representation of SSNs in your environment there. But in Campus Solutions, it's a little bit different because we have, for instance, an admissions area where we have many SSNs in that area of the system that aren't necessarily in the person table. They're students trying to get into the school or other people like that who aren't necessarily a part of the campus community yet, or maybe never will be. Anyway, there's that. Same thing with the alumni area, though there's a number of people that aren't necessarily in the person table. So we had to go through some extra steps to basically walk through and find all the unique SSNs in the system. We had to look through certain tables. And with that, after we had that, we created a seed table of all the unique SSNs in the system. And basically, from that seed table only had two columns. The first column was their real SSN, and the second column was their masked SSN. So we go through and pre-populate that table with their masked or fake SSN. And then that would be used whenever we'd encounter their SSN finish the project that summer. It took about 2 months of working development time, elapsed time to get through the issues and develop a process and a procedure and being able to clone our PeopleSoft databases. And then we were able to implement it through our PeopleSoft environment. I think we started in late June, finished development in the summer, and finished rolling it through our entire environment by October. So it took a couple months, but overall it didn't take too long after we figured out the rules and the process we wanted to follow. So lessons learned, as always, it was a change for groups. So when you're changing things the way people have been doing them for many, many years, that causes anxiety, stress. Functionals in particular were somewhat stressed that they weren't going to be able to see SSNs that they're used to seeing when they're doing certain testing procedures. So it took a number of meetings to work through and achieve a level of comfort there, let's say, in terms of working with the new data sets. So it took a little time to get through that. And it took some time to develop the rules for masking, as I mentioned, figuring out which algorithms to use and how they work and do they achieve the result you want. And as I also mentioned, working with PeopleSoft Campus Solutions and SSN is a little bit more challenging than modules like just HR payroll, where their SSN is distributed throughout the system and somewhat hard to nail down to any one area. I'll talk a little bit on one of the next slides about external file processing. That was one of the challenges we didn't have a great solution for, and by external file processing, I mean when you're dealing with external agencies, say healthcare providers or student areas, say admissions type agencies or testing agencies or the government for grants and awards for students. It's not, once again, it's not got anything to do with production, but when we were interfacing with their test systems or they with our test system, it created a challenge if they had systems with real SSNs and we had systems with our random or masked SSNs. So talk about that a little bit. And then keeping SSNs in sync by masking from a gold copy. What do I mean by this? Basically, before you mask, if you go into your development environment and look at John Smith, his SSN is 123456789, and if you look at it in the test, it's going to be the same thing. But if you don't create your dev and test from the same gold copy after you mask, they could be different random values. So each run can end up with different random values, and that might pose a challenge if you want some consistency between certain environments. So the idea here is to run through this process, create a gold copy, and from that gold copy you push out your training environment or your dev or your test or your QA or whatever you need to support in your role. So we definitely settled on using a gold copy for all our cloning out after this was put in place. And we ran into something that was a little hard to deal with, but at this point I think, and that is SSNs in text fields. So sometimes there'll be a notes, or a comment section when you're dealing with a client or with maybe a parent for a student or who knows what. We would find SSNs embedded in the text or the comment about some correspondence that went on. Those, of course, are a little harder to find, but we did eventually figure out some string searching, and all we did with them was simply eliminate them out of the cloned copies. So we'd look for them and change them to nothing, or change them to 9A's or something, because it really wasn't important, but we didn't want them in there. And the last point I'll bring up is validating your work. A lot of people were asking, well, how do we know that we changed them to random numbers, and how do we know that we are consistent, and how do we know we didn't just move them around and end up with someone's real SSN being with someone else? So there was some work on how to validate, how to confirm that we were happy with the results, and I'll talk about that in a slide or two. So this slide is that whole external file transfer, and like I said, we don't have a great solution for it because I don't think there is one. If you're working with an agency that in their test environment has real SSNs and your environment you on SSNs unless you create a small sample data file and send them back out of your test system. Alternatively, we thought we could also, for some types of testing, send it from our production system. It really depends on what you're testing, and it required us to think a little bit more about what we were testing over the years and how we've been doing it. And in the end, I don't think we've run into any showstoppers. It just required a change of practices. Often we were just seeing if the file formats were compatible, so it didn't really matter if SSNs were real or not. And if they really needed the real SSNs, as I mentioned, you could correctly enter 10 or 20 of them manually. In other words, open the data file up, correct 10 or 20 of your random ones back to real, and feed them over and see if they are loaded correctly. So, like I said, no great solutions, but at least we developed workarounds that kept things moving. And the other topic of validating results. So, how do you validate results? Well, there's the obvious one. You go in and look at the records. Both technical and functional staff could go in and do this and work with their favorite test records, favorite people, walk through, make sure the data made sense. So there's the visual inspection. You reviewed error logs. There's a bunch of logs generated. You can walk through them and see what kind of errors are kicking out. And then we basically generated a set of scripts that went through that validated that the masked SSNs don't match your original ones, and that they are unique, and that they're consistently changed. So we wrote some additional scripts at the end to go through and achieve a higher level of sort of comfort and satisfaction that we were indeed achieving what we wanted to. So the data masking solution deployed, we used the Solix EDMS data masking along with our Oracle Enterprise Manager data masking pack. So we went with both, and from our perspective, as I mentioned earlier, I was charged with reviewing products and coming up with a solution. So we did review a number of products on the market at the time, and I think there are a number of good solutions, and in our case, we felt this was a good fit for our environment. I thought this solution was relatively complete for what we wanted to do, and it was simple to maintain, and I will say that again. Since we've implemented it last year, we've had almost zero maintenance on it. It just works. There's been some updates to PeopleSoft that maybe have had a new column with an SSN or something like that added, and we've simply added them into the process. But other than that, it's really been lights out, and no one even notices it anymore, which is really the biggest thing for something like this. It's just off the radar, and it works. And from our standpoint, we have a large commitment to Oracle solutions. We have Oracle databases, PeopleSoft, we have Enterprise Manager, we're familiar with that. And in this case, Solix is a partner in terms of the software and with Oracle, so that they can really facilitate the management of the metadata. So that being one of the real keys here is to manage your metadata that links, that says, here's an SSN in this table in PeopleSoft. Like, as we all know, something as large as PeopleSoft, there's so many tables that it is a very daunting task to think you're going to do that. And we also had some consulting engaged here to help us get through the implementation, and I would very much recommend that. So in conclusion, I would say the first thing to do is make sure you have policies on confidential data and make sure that those are clear from your higher levels, and then it's possible to align your IT deployments with your corporate or institutional policies. If you do it in the reverse order, you're not going to get very far, and you're going to have to rework it. And I think data masking is a component of your security strategy. It's not the only one, but it's certainly an important one. So, it's defense in depth. And the last point, which I've already mentioned, is that if you partner with a vendor here, I think it's a very cost-effective solution to get to the goal. And that's basically it for my slides. So I'll turn it back over to Russ at this point.
Fantastic. Thank you, Tony. we've got several questions, and for those folks out there, if you've got any additional questions, please go ahead and send them via chat to the host. Tony, I've got a couple here for you that have come in. First question is, how long does it take to actually do the masking run?
Good question. So in terms of us and our environment, before we had masked our PeopleSoft database, which our database is about, we're not large, we're a university, it's about 350 gigs, our database. It used to take us about 5 or 6 hours to clone a copy of that using, given our bandwidth and the technology we have, which was good enough. And when we then added the masking on top of the cloning process, so I think really what we're looking for, what's the delta here? That added about 2.5 hours onto that process. Hopefully that answers your question. So in total, it was about 8.5 hours after that.
Great, thank you, Tony. Next question. You mentioned you've got 4 or 5 fields, Social Security number, credit card. What about fields like name, email, address, some of those others? Were those considered?
Oh, sure. There's a long list of fields that, depending on what you're trying to achieve, you can say a person and their address is quite confidential. You don't want that getting out. But in terms of what you have to provide credit checks for people to, the way I understand it, and I'm by no means an expert on this, is that if you release their name with their SSN, you have to provide credit checks for them. So that was the first line, was we must absolutely mask the fields that are require sort of a legal response. But and people have been asking since, well, now what should we do? Should we go ahead and mask name? Should we mask addresses? There's a lot of information in there that you can mask, and I think the thing you have to think about is every time you add fields and columns into your repertoire of what you want to mask, you're increasing your overall time to mask. So it's basically a lot of physics, and that basically being you're looking at a table, you're taking a column in that table and you're altering it. And there's just a certain amount of time that it takes. So the more columns you add, the more time to your overall cloning process. But yes, they are, depending on what sector you're in and what you're dealing with, they are certainly items I would consider sensitive. If not, maybe they don't rise to confidential, but they're at least sensitive.
All right. Next question is, you're talking about 4 or 5 elements here. Any idea how many tables that covers?
Yeah. I don't remember the exact number. It's probably in the low thousands. I don't remember exactly. PeopleSoft is at some 25 to 30,000 tables, at least in our module at this point. Of that, we use so many of those tables. Some are deprecated, some are just sitting in there. But and things like SSN are all over the place in PeopleSoft, especially in campus solutions. So yeah, I would say up in the thousands.
All right, and then the last question I've got is, any estimate that you can share on the cost of the data breach?
I'm not sure I want to share that right now, but it was 10 times what the project cost in the software.
That's a good way to answer it.
But it was an order of magnitude more than the solution to fix it costed. So I'm a little wary of talking about that, but the numbers were certainly, well, I don't know. I don't know the exact numbers. I was just told it was a lot of money. Providing free credit checks for, the number of people we're talking about is a significant fee. So I'm kind of around that question.
No, Tony, I think that's a great answer. clearly, for your perspective, there was good ROI on this project.
I think a huge one, and unfortunately it was done after the hole was in the dike, so to speak, and the water was spilling through. But it's been done, and hopefully it will take care of us for a while.
So, sort of after the horse left the barn, basically.
Yeah. Basically, at that point, it was damage control instead of proactive security measures.
All right, and I've got one more that came in. Now that you've completed this, how would you compare the solution approach the way you've done versus doing scripts?
The way we've done it, I think, is sustainable. I don't think if we had done scripts, I don't know if we'd be done yet. If we had done it using scripts, we might still be working on it. And I certainly don't know how we would keep that maintained. I think this is overall more cost-effective solution. And of course, that depends on the size of your system. If you're masking a system with 10 tables in it or 50 tables, then maybe doing it with scripts is a valid approach. But when you're talking about larger systems and maintaining the metadata needed to keep it valid, keep the system working, I don't think it's practical to do it the manual script method.
Excellent. That's all the questions that have come in. Tony, I really want to thank you for taking the time to share that with everybody here. These type of sessions are really valuable for people who are beginning to think about masking solutions for their ERP applications. And again, we try to have this type of series to cover different types of applications, whether it be archiving or subsetting or application retirement. Appreciate you taking the time to share that with us. So thank you very much.